Welcome to Lifting the Lid on Technology, a podcast series brought to you by Softsource in association with New Zealand's leading IT vendors and experts. I'm Barry White, VCIO Principal Consultant at Softsource. In this series, we explore opportunities and challenges in the world of IT. Today, I'm joined by Ben Young, Head of Cloud Products at Softsource vBridge. In this special product launch episode, we discuss the latest cybersecurity threats, why immutability has become so relevant, and what makes the new Indelible backup solution from Softsource vBridge an innovation in data protection. Well, welcome, Ben, to the podcast. Although both of us work for Softsource vBridge, I think as a precursor to what we're about to talk about, it's probably worth saying that we both live in different cities and we haven't really spent a lot of time together at all. So really looking forward to our chat today and learning more about what you do and some of the projects that you're working on. You're a development manager. You describe yourself as gatekeeper for my cloud space, but tell us a bit more about yourself and about the stuff that you do at vBridge.
Look, thanks for having me. I'm really excited to be on here. Bit of a background into me. I really a background in programming. That's where I've sort of come up through IT, worked for a lot of corporate enterprise companies before starting at vBridge when it was very young. And obviously now we're part of a much bigger family with Softsource. And when I joined vBridge, that kind of really kick-started my career into learning about storage devices and virtualisation and all the other products that sit around the periphery. So thankfully had some really interesting discussions with lots of vendors, in particular around integrating our My Cloud Space product, which is our web portal for customers to interface with all of those different platforms, looking at how we can productize the various different hypervisors and storage platforms that we have here at vBridge. That's kind of the background and why we're here today, talking about, I guess, ransomware immutability and our new Indelible backup product.
Yeah, obviously we're going to talk about object storage, and I guess before we kind of get into the specifics of that, I think it'd be kind of useful for anybody listening to get a bit more of the sort of history around cloud-based storage and some of your perspectives. I guess I'm really keen to hear from you about, what are some of the things that customers, should be thinking about? What are some of the limitations, for example, around some of those traditional storage solutions when you compare them to what's evolving in the public cloud?
Public cloud aside, I think that the challenges are the same and in a way they have been the same for a long time. It's data growth is exploding. How much storage do I need? Big capital expenditures. I think we've seen customers move to more of a cloud consumption-based model because that takes away the, how much storage am I going to need or how much capital budget am I going to need to go and ask for to buy storage array X. Whether or not you're consuming kind of block-based storage in the cloud or on-premise, that doesn't really matter, just how you kind of pay for it and does. I think if we take a step back and perhaps look at storage platforms as a whole, I think you could probably break it down into three main sort of categories. We've got block storage, which is obviously your typical storage that virtual machines and high performance things. Typically, these are things like SANs that are connected, to compute clusters. They typically deliver high performance. The newer arrays typically are all flash now, no spinning disk, so really low latency storage. Great for things like VMs and SQL databases and things like that really need that high performance, low latency storage. But of course, they don't scale as well as, say, something like object storage, which we'll get to. So, once you start talking about hundreds of terabytes or even petabytes, it becomes very, very complex. So typically, the scaling at that point is actually just buying more arrays. Then you've got your data scattered across different arrays, which obviously has its own unique challenges. So block storage obviously typically used for most things in corporate enterprise, traditional storage. Then loosely there's file storage as well. Obviously these kind of sit on like block devices in a way, but these types of services are typically presented over the network. So SMB, NFS, used for things like file shares, but usually lower in cost, performance can be pretty good for what they do. Delivering files. There's smart little caching devices, and now you can stick in these to sort of cache the frequently accessed files up in the device, but not good for running high performance, low latency, and again run to the standard typical scaling limitations, even more so than big storage arrays. You might be talking about hundreds of terabytes or even lower before you start needing to buy new devices. And then, of course, the new kid on the block, well, not so much the new kid, would be object storage. So this has really been designed with not only scalability, but also durability at its core. And instead of having this hierarchy file system, everything is stored flat in a single namespace. Your data is actually, when it's stored, it's also stored alongside a whole heap of metadata. That metadata lives in typically very fast devices on those storage arrays. And then the data and the blocks are scattered around using an erasure coding, which is sort of not RAID, but we'll for the sake of the podcast, we'll call it the protection of that data, and it's split up, and that's its kind of parity. So it allows basically people to query this data using that metadata. So we might want to search for it. So we might want to store a photo of our family, and we've tagged it with holiday X, and then we could actually query the array and say, hey, give me your files for holiday X, and it would know where they are and allow us to access it. Or if we know the ID of the object, we can query it and get it back. It also differs in the way that it's presented. Like block storage is typically connected to the compute by a fiber channel or iSCSI and other bits and pieces in the data center. File storage, like we talked about, SMB and FS, but object storage is just accessed over HTTP or HTTPS, which really allows for any device to connect to it and consume it. The real key tenet here is like petabytes are nothing to an object storage platform. It can grow, almost infinitely. And that's really what makes it kind of the next gen of storage. And that's why we're starting to see support for various different software vendors and tooling to be able to use these storage platforms, because it is really built for the future. And saying that, it's not a replacement for high performance, block storage in the data center. You're not going to run your SQL database on this. But in terms of unstructured data, perfect place for it.
So I guess in layman's terms then, some of the key things there is obviously cost as a factor. So you talked there about scalability, and with block storage, if you want to scale to very large amounts of data, that can get pretty expensive. You touched there on metadata sort of being an inherent sort of characteristic of object storage, which if you're dealing with traditional storage, you'd have to have some sort of application layer on top of that storage in order to achieve that, right? Whereas what you're saying is object storage inherently has those types of characteristics sort of built into it from a sort of architectural point of view. Have I kind of summed that up right?
Yeah, that's absolutely right. So instead of, like you could think of it like the Windows file system, there's a hierarchy, there's kind of metadata embedded through all those files and folders and things, but it is a hierarchy. Whereas when we're talking about object, it's almost stored at one level. All the files just go into this kind of, we'll call it a root directory for lack of a better term, but all of those blocks are getting, all those blobs are getting written into the object store alongside its metadata. And that metadata is really the key to the whole system around being able to search for it or, and query the data in different ways to find those things in the file system or lack of in this case.
So you touched on immutable data there, and that's a term that maybe some people listening to this may not be particularly familiar with. Do you want to talk to that as a little bit? It's kind of becoming a bit of a buzzword at the moment when you're in the sort of backup and the ransomware sort of world. But do you want to talk to that and just talk a little bit about why that's important? And even, for example, around sort of insurance of data and redundancy of data, et cetera.
Yeah, I mean, immutable is definitely a buzzword in the market. If you work in the industry, I would have thought you've probably seen it 10 times this week, or certainly the word ransomware. There's no doubt that ransomware attacks are becoming more common. In fact, it's getting quite crazy out there. I think I saw a stat the other day. Globally, it has gone from something like $325 million US dollars in 2016 to $20 billion this year. So you can see they're ramping up. It's becoming more expensive. You can now hire agencies to effectively perform ransomware as a service. So hence the reason it's in the market, because it's causing big pain and big disruption to lots of organizations, not just in the US and not just in Europe, but here in New Zealand as well. So as part of that, we've also seen moves from insurance companies globally to either get rid of cyber insurance policies completely. It's now down to a few that will actually offer it. Certainly the reinsurance for it. And even if they do have them, they're becoming very expensive. And they're also having a whole heap of clauses put in there around, I guess, ways out for them to not pay out, or maybe putting certain limits on caps on various portions of the policy. So, that world is changing. And I think immutable storage is going to play a big part potentially in new insurance policies and I guess ransomware protection going forward.
Do you think some organisations are perhaps not fully aware of just what their exposure is there? Maybe they've got a better sense of security than maybe they should have. They're not really aware of what the potential loss could be from data loss, and therefore they perhaps don't focus on this enough. Do you think that's an issue amongst some of the customers that you've spoken to?
Yeah, I think it's a massive issue. I think a lot of customers haven't really sat down and went, okay, if we lost our servers for a day, an hour, a week, what would that cost us in revenue? What would that cost us in reputation? It could be a very hard thing to kind of quantify what that is. But I think, certainly here at vBridge, we went through it last year. We've become ISO 27001 certified, and a part of that was just really looking at our exposure, looking at any risks we had in the business, tightening up things, really putting policies and procedures in place. We already had a lot, but we have a lot more now. And we sit down every quarter and actually assess either new risks or new projects which might have potential cyber risks. And we assess them and work out how to mitigate them. They can't all just be solved, but sometimes we can mitigate where possible. Other times the risk might be so low and we're willing to accept it. I think not enough companies are probably looking at that or doing similar programs of work within their business to understand, the real cost of being cyber attacked. And the landscape's changing so rapidly. It might have been back in the day, the exploits were just, someone's clicked a link in their browser and, that's it. Whoopsie, that the antivirus engine didn't pick it up. But, we're seeing attacks through social media, social engineering, email and phishing is still obviously a huge part of that. Various different vulnerabilities and exploits and 0 days coming out of software, like the RDP bug, or even the Exchange more recently, which I know, personally a few companies got bitten by, and in fact one customer here hosted at vBridge who still had a hosted Exchange box. Thankfully didn't have ransomware put through their network, but they did have all the logging to indicate that someone did come knocking on the front door and did exploit that vulnerability through their Exchange box. So there's so many moving parts to IT environments now that it's hard to get away from.
Yeah. So I guess we'll talk about immutable data then. What really is the technology under the hood, as it were? I've heard this term object lock. Maybe you could explain what that is and how that works, and how does that improve, if you like, a customer's footprint when it comes to the redundancy of their data and the security of their data.
Typically we would write files in. Let's pick on a file share. We write files in, and most organizations would have some permissions set on the files and folders to say, maybe the accounts department can't delete this and only IT admins can, that sort of thing. But of course, if someone hacks the IT admin's account, they could delete it. If someone manages to elevate themselves into those roles, they could delete it or change, modify it. So under the hood, so to speak. Object lock is a name used commonly across S3, so object storage vendors. Obviously, sort of started with AWS. They're the ones they're the inventors. They're the ones that kind of control the spec. But a lot of the other vendors are now catching up and support object lock or immutability. Some of them have different sort of fancy marketing terms for it. But that's what we're really talking about here, is that object lock technology. So what that allows a program to do is when it writes the data in, aside from all the other permissions and access control that might be on that file, when it writes the file, it will tell the object storage this cannot be deleted for, and then your determined amount of time. So a really simple example of that will be with Veeam, as part of a scale-out backup repository or a GFS policy. When Veeam writes the data into object, it will then tell the object storage that backup retention point cannot be modified, it cannot be deleted until that retention period is up. So typically the retention periods are, it might be a few days or a couple of weeks. It's that sort of short term, oh no, someone's come in and tried to delete all of our data. But it can be up to, years worth of data if that's, what you need in terms of legal hold or other things like that. So that's kind of what we're talking about here, is that object lock technology that's built into object storage as a platform.
So again, and these are terms that I guess some people are familiar with, with tools like SharePoint and some of the other sort of enterprise applications for managing data and managing their sort of compliance environments. But what you're really saying again is the characteristic is inherent in the actual storage itself. So rather than being reliant on an application layer to manage this, which of course can also be wrong or can be corrupted or can be potentially manipulated by people who are up to bad things. What you've got here is you've got this level of redundancy and these policy rules, if you like, baked into the actual storage operating system itself. So it's much closer to the data and therefore far less likely to be corrupted or damaged in some way if those rules are applied. Have I summed that up correctly?
Yeah, that's exactly right. So we run a Cloudian array here, and we're about to obviously install a brand new big node, big cluster up in Auckland to support Indelible. And so even as the operator of the object platform, we cannot get in and delete the data. It is part of, like you say, it is part of the storage system, part of the platform itself. The only way to get rid of it would literally be to go in and remove it from the data center and get everything, which obviously is highly protected in itself. So, at a software layer, it cannot be removed at all, which is great, which is why the industry is talking about it.
Well, that's a great segue. Thanks for that. You talk about rolling out some of the new architecture and hardware, if you like, that's supporting this new service. So let's kind of turn to that new service, and maybe you could talk a little bit about that architecture and about maybe some of the hardware considerations that your team's looking at in terms of its deployment and the architecture of that.
I guess what we're talking about is Indelible. That's our new backup product that we're launching into market. We really felt that there was a big gap in managed backup. So obviously vBridge is an IaaS provider. We already do backups for lots of our hosted customers, but there's still a lot of customers out on premise that still have on-premise data centers or maybe even edge deployments. So we sat down and we said, well, how can we do this better? How can we use the best of breed technology that's out there today? And kind of what are the key things that we want to cover off as part of the solution from day one? And then what can we look at for day two? So some of the things we looked at was, we wanted this to work for businesses of all sizes. We didn't want this to just be the corporate enterprise end of town. If you've got 2 or 3 servers on site, we can deploy a small micro server, all solid state drives in it, which makes it really fast to restore from, as well as we can back it up as fast as the storage on premise can deliver it from the customer's side. And then right through to a large enterprise who's obviously not going to fit on a micro server. We can scale the on-premise node up as required. The other thing we really wanted was like a simple and predictable costing model. I think we've all been onto the various public cloud providers who I'm not going to name, and the calculators are there, and you dial in all the sliders and enter in random numbers that you think are right, and it tells you that it's going to cost you X amount of dollars a month, and it never is that. So it's complicated. So we wanted a simple model, and at the moment it's looking like we're going to run with literally storage consumption plus the number of protected assets, which is about as simple as you get. There's no egress fees, there's no transaction charges or anything like that. We wanted it to be fully managed. So we didn't want you to have to worry about setting the schedule or managing the on-premise hardware, monitoring hardware faults or backup jobs that aren't running. So we've got centralized monitoring and reporting on all of that stuff that we can make sure that your backups do run every day and that the hardware on site is healthy. We wanted flexibility in the way that we could recover, and part of that was what came down to kind of what software stack we used. So we're a big Veeam shop here at vBridge, and that's end-to-end made up this new Indelible product too. So the customer may not want to restore back on site. They might have had a complete data center failure, a fire in a server room, anything could have happened. So being able to take the data from on-premise, but it also scales out, which we'll get to in a minute, and actually be able to restore it onto our IaaS platform here or back onto another piece of hardware was key. Also, Veeam at its heart has a number of instant recovery functionality. So we don't need to worry about time to recover. We might have a 4 terabyte server, and 4 terabytes is 4 terabytes no matter how fast your storage is and network layer is. The time to restore all that data to a platform could be hours, whereas Veeam at its heart has these instant recovery technologies which allow us to spin up the machine live out of backups actually onto a running compute cluster and actually redirect the writes to some fast storage within the data center, which means your machine comes up in minutes, and there's a wee bit of a performance hit while it's there, but we can live storage vMotion it out of the backups effectively onto production compute and storage, which is mind-blowing. The time to recover is lower. Some of the other key things I guess we wanted to cover off was we wanted it secure and separate from the customer's network. So this appliance, although it's connected to the network, is a Softsource vBridge asset. It's in its own IP space. We have only the required access into your compute cluster and very limited back the other way. The customer can't get into this thing. It's all secure out, which provides another level of resiliency for ransomware attacks. Obviously, immutability, very key part of the solution. We are using that from day one out in our object store. So that's going to be hosted on a new big HPE cluster with Cloudian on top of it, much like we do down here in Christchurch. And the on-premise is actually going to be able to scale out to that. So what that means is the backup restore points that get generated on-premise will actually hit the performance tier, and by that, the performance tier is the local solid states within the device on-premise. And then as the backup points start to age, they will get copied out and scaled out to object, which means we no longer need hundreds of terabytes on-premise. We only need enough for the last few days for that instant recovery functionality if we need to do that on-site. But it means in terms of what's online and available to the customer to restore from, it could be 30 days, 60 days, 90 days. And again, we're flexible on that. The solution's flexible depending on how the customer wants to retain that data. Obviously, encryption, and not only in transit, but at rest. Every customer is going to be encrypted, obviously with their own encryption keys, both locally and out in the object store. And then this is where sort of we start taking a different spin on what managed backups are. And this is where we want to not only make sure that your backups are running and they're fast and it's reliable and all that good stuff that you would expect, but we want to take it a step further and actually start doing some automated testing and auditing of those restore points. So the ability for us to effectively connect to the backups and restore that VM and prove that it had a heartbeat, to prove that the VM does boot, that it's not corrupted. So really taking that kind of validation of those backups a step further than what's typically been done in the past.
I know as a virtual CIO, when I'm reviewing organizations' redundancy policies and their methodologies, that whole scheduling of testing, if you like, seems to be a real challenge. And a lot of them start out well-intended, but they struggle to do them in a structured way. Is that a problem you're really trying to solve here, is through using automation to achieve that, you can start to, again, provide more surety around those sorts of things?
Yeah, I mean, it's one of those things that's really hard, right? You're dealing with a lot of data sitting there, and it's a pretty unsexy thing to go, oh, my backup's valid. And a lot of people just go, well, the console said that the job ran, so that's kind of as far as they take it. Veeam in particular has got a number of kind of functions within it that, you can verify the data is valid, but that's not really spinning up your VM. When we typically see customers do DR tests, and they might be in isolation where they spin up their environment or parts of their environment, we often see other issues. Some patches might have been applied, and then all of a sudden the VM's not booting. That can't be validated by us backing up the blocks. So really testing that backup restore point from last night does boot to Windows, and Windows gives us a valid heartbeat back as a first step. We're really excited about, and kind of skipping ahead a little bit, which I was going to talk about, which is phase 2, which because of the product suite we've chosen, it's going to allow us to create some advanced data labs. So simple example might be, you might have an application that's got a SQL box and a web server. Allow us to spin those two servers up together and then run a script that might query, an API that's on that web server, which then returns data from the database. And that really proves as an application group that the application's working, those backups are valid, everything is good. And then that leads naturally into automated DR tests, and that could be on a monthly or a quarterly or an annual basis, testing from those restore points, which is in phase 2. We don't currently have that in scope for phase 1 because every customer is going to be different. So we need to kind of work out the nuts and bolts a bit there, but that's kind of where we're heading with this product, is not only making sure that your backups are there and it's immutable and that we're doing all the good things around policy, but we're also doing all the smarts on top of it, all the automation, all the validation and checks that you might want. And hopefully that feeds into insurance policies and being able to get the cover that people may want for that sort of thing.
So you touched on the product suite there, and you also mentioned HP and PaaS in there. Do you want to tell us more about some of the choices there? I mean, why HP? What was the appeal there, and how's it really going to help you as you start to build the service out?
Yeah, I mean, HPE, so from a hardware perspective, it's HPE pretty much end-to-end, certainly from the stuff that goes on premise. So HPE obviously have a large range of devices. It's not just one size fits all. So we were able to procure things right down to a micro server, which has all the kind of enterprise stuff, but in a small form factor, and also a low cost. Things like ILO and all those remote management tools. It's not just sort of an off the shelf server that we've built and just put on premise, and we don't have all the mature products and services that we can query, and also have a support contract on. Right through to what we're looking at in the data center is the HPE nodes that we're putting in for the Clownian thing. Just the Apollo nodes that we're putting in worked really well. They were the right spec, got a really nice kind of density in them in terms of the number of drive slots, as well as we're able to get the sort of enterprise solid state drives in them. So that's another key point of what we're able to do through HP is we didn't want any spinning disk in the solution whatsoever. We wanted this thing to be as fast as possible, particularly if we're talking about being able to recover someone's data or multiple servers out of a backup repository. We needed that to be as fast as possible, and HPE were able to deliver that. And I guess that kind of feeds into, we talked about scaling our object store and how well that scales as a platform. We wanted a solution as a business that we could scale the object blocks in, and HPE GreenLake allowed us to kind of do that. So as we outgrow the initial size, or as we start reaching capacity on the initial cluster, we can just start plugging in more nodes through that GreenLake program that allows us at a kind of an agreed rate. So we have predictability on our costs going into the solution, which in turn allows us to kind of provide predictable and static in a way, costing through to our end customers. So yeah, that's our main hardware selections for the platform. And then in terms of software, I mentioned it's Veeam end-to-end. So Veeam Backup and Replication Enterprise on-premise. We obviously use that here in the data center for being able to connect to it and spin it up. Veeam have got all the smarts in it and around this automated backup checking and advanced data lab functionality. And then the object storage platform we've selected is Cloudian for that. We reviewed a number of vendors there, and when we made our selection a year and a half ago for the Christchurch cluster, they were the one that supported most of the S3 spec. It's an important thing to note when you're choosing object storages. Not all object storage is the same. I mean, even between, like Azure and AWS and Google Cloud, they have, various differences of support and what they support in terms of the spec. And when we looked, Cloudian for us had the best coverage, and they also had a really great API which allows us to automate the spin up and spin down of various different buckets and users and get user credentials and things. So that's kind of it, really. It sounds like it's simple, but there's a lot of moving parts.
No, it sounds it. I mean, that was probably my last question I had, and I guess maybe on a slightly lighter note, but you talked in there about egress, and I guess because in the object storage world, you are by definition probably talking about, as you say, large amounts of unstructured data, and therefore the volumes can get pretty sizable. Do you think customers are aware of just how expensive egress costs can be, particularly if, for example, if you had to pull back data in anger and you had, multiple terabytes of data? Customers, I think, probably don't really realise how expensive that can actually get, right?
Totally. I mean, there's many cases online of people getting bitten by exactly that, by design, and it's very clever. It's very cheap to put data in, and it's very cheap to store it on a per gig rate. But as soon as you want to do anything with that data, and that might not even be egressing, if you're chucking through a lot of API transactions, they've got so many metrics they can bill you on, that costs can spiral out of control, particularly if you're not in control of what's reading it. And, if someone's written a bad query that's listing the directory over and over and over again, those list requests even are going to add up over time. But yeah, as you mentioned, the egress is really where they get you, and I think you've seen that even from challenger kind of object storage providers. That's a big part of their marketing play too, is the egress costs. I think I saw something the other day from Cloudflare saying that it can be up to sort of 8,000% markup they've estimated that AWS is putting on IP transit alone. And it varies from region to region depending on the costs of that transit, but a lot of the time they own all this fiber anyway. So yeah, getting your data out can be very costly, particularly when you're talking about large amounts of data. Yep, if you've got 1 or 2 gig up there and you need to get it back, then it's a couple of dollars. But if you're talking about wanting to restore a couple of 100 gigs, let alone terabytes of data of your backups, buckle in and wait for the invoice to come in. But if you've put it in there, then and you need it out, there's no way around it, right? In fact, I think I did read the other day someone. Once AWS announced that they're now going to start putting charges on into zone, so like say Sydney Melbourne zone transfer. Someone joked that it's now cheaper to buy a 1 terabyte hard drive on Amazon.com and get it shipped to your address than it is to pull out the terabyte of data from your object repository.
Hey, look, Ben, I'm really conscious of the time, and look, you've given us a lot to think about, and I know you're just an absolute fountain of information when it comes to this whole area, and I think maybe at a future date, you've given your experience, and particularly around Veeam as well. it'd be great to get you back on the podcast to talk about some of those topics as well, and to dig into some other areas. There's also my cloud space, of course, which we did get time to touch on today, but it'll be great to talk about that at some point in the future as well. So love to have you back. But just want to thank you for coming on today, and thank you for sharing that information with us and about the new service that's coming up. And I know everybody will be looking forward to hearing more about it.
Absolute pleasure. Look, happy to be on anytime. Come back. I'm there. I'll rent.
Sounds great.
As required.
I'll take you up on that. Awesome. Cheers, mate. Take care.
Thanks. Bye.
Thank you for tuning in to learn more about the state of data security and our exciting new Indelible backup solution. Keep an eye out for future episodes of Lifting the Lid on Technology, where we'll look forward to welcoming you back.